Okay, so today we are going to prove that for every integer x, if x is odd, then there exists an integer y such that x squared equals 8y plus 1. Now the method we are going to use for this is going to be direct method. I'm using this proofing method because we can solve this question easily. We can prove this question easily with just known facts and rules and no further assumptions. And as you will see in this video, we are going to use a lot of different rules and laws. And the first law we are going to use is the law of integers. So if we have 2n, we know that this is even, but when you add a 1, it is going to be odd. Now we look back at the question and we have x is odd, and this is odd, which is why we do this step, making them equal, because both are odd, both are equal. Now, to further simplify, I'm going to make this even. So we have the first part of the equation. We have the x squared. But we unfortunately do not have the other part yet. But further simplification will get that. Now, whatever you do to this side as a rule, you have to do the other. So this has to be squared as well. Now, I'm going to expand and solve this. We are using FOIL to do this. And when I FOIL, I get 4n squared plus 4n plus 1. Now, we notice that we have plus 1, which is this part. Now we just need the 8y. So what we're going to do is we're just going to worry about this part of the question. And what we're going to do next is we're going to factor that. So I have 4n plus 1 when you factor it out. Now, when looking at this, you can see we have two consecutive integers. And the law of two consecutive integers say that one of these, n, or n plus 1, one of them must be even. Now, let's assume n is the even number. You are going to replace that with 2k. The variable doesn't matter, I'm just showing the even part. Like we had the 2n over here, same idea. And when we put that into the equation, we have 4 times 2k, so right there, and then just times n plus 1. And when we simplify this further, so I'm just multiplying this right now, k, n plus 1. Now, this can also be a y, which will give us 8y, which is that. But if, let's say, the number is n plus 1, that's the part of the consecutive number that if that is an even number, let's see, then we would replace it with the same idea, 2k, and put it into the equation. 4n plus 2k, we would get 8, further simplifying, and k. Now this can also be replaced with y, and with the same idea, you have 8y. So it does not matter if you're using n or n plus 1. Either way, the idea is that you can replace this with an 8y, as I've proven, which in total would give us, and we get the 1 from back here, remember? And that is it. Thank you.